Before we dive into tonight's story, don't forget to subscribe to the channel and hit the like button. Every night we explore the hidden secrets of nature together, from the strangest prehistoric beasts to the most mysterious animals of our oceans. Join us so you never miss the next journey. Octopuses have 3 hearts. They move with 9 brains. Their blood is blue. They master the art of changing colors, of camouflage, and even invisibility. These short facts sound unbelievable at first, but they are only the beginning of a much larger mystery. To truly understand what kind of creature the octopus is, we need to dive deeper into its hidden world. A world where intelligence takes a completely different form than the one we know from human beings. Let us begin with the 3 hearts. 2 of these hearts are dedicated only to pumping blood to the gills. The 3rd heart is responsible for circulating blood through the rest of the body. This alone would make the octopus unusual, but there is more. When the octopus swims, the main heart that pushes blood through the body actually stops beating. That means swimming exhausts them quickly. This is why octopuses often prefer to crawl along the seafloor instead of swimming. It is an energy-saving tactic written into their biology. Now imagine the 9 brains. There is one central brain located in the head, but each of the 8 arms has its own mini-brain. These local brains are capable of making decisions without consulting the central brain. An arm can explore a shell, feel around a crevice, or even open a jar independently, while the main brain focuses on the larger task at hand. This distributed intelligence system makes the octopus one of the most flexible and adaptive animals in the ocean. Their blood is another astonishing detail. Unlike humans, whose blood is red because it uses iron in hemoglobin to transport oxygen, octopuses have blue blood. Their blood is copper-based, using a molecule called hemocyanin. Hemocyanin works much better in cold, low-oxygen environments, which is why octopuses can thrive in deep, chilly waters where other creatures would struggle. The color change ability is another one of their superpowers. Under the skin of an octopus are millions of pigment cells called chromatophores. By contracting or expanding these cells, the octopus can change color in an instant. They can blend into sand, mimic the color of a coral reef, or flash warning patterns to intimidate predators. Some species can even change the texture of their skin, creating bumps or ridges that perfectly match the rocks around them. This is camouflage so perfect that predators swim right past them without noticing. These features are not random tricks of nature. They are the result of millions of years of evolution shaping the octopus into a survival expert. Let us now look at how an octopus hunts. They are patient predators. An octopus will hide in the shadows, pressing its body flat against a rock, waiting for the perfect moment. When a fish or a crab comes close, the octopus strikes with astonishing speed. The arms shoot out, the suckers grip tightly, and the prey has almost no chance to escape. The strength of the suction is incredible. Each arm is lined with powerful suckers, and once they grip, it is nearly impossible to break free. Some species use venom, paralyzing their prey before consuming it. Others rely on their hard beak, sharp enough to crack the shells of crabs and lobsters. But beyond strength, what makes the octopus a true hunter is strategy. They use their intelligence to trick their prey. An octopus may pretend to be a rock, waiting in perfect stillness until the prey passes by, or it may stir up sand to create confusion. There are even octopuses that mimic other animals, like flounders, swimming in a way that makes predators ignore them until they strike. This ability to plan, to deceive, and to adapt makes the octopus a rare kind of predator. For humans, This behavior is fascinating because it feels familiar. We see something almost human in the way an octopus solves problems. Scientists have documented octopuses opening jars to get food, escaping from aquarium tanks, even remembering which people fed them and which annoyed them. There are stories of octopuses that deliberately squirt water at specific humans they disliked. These are not instinctual behaviors. They are evidence of something closer to thought. And this brings us to the larger theme of our story. The octopus is not just an alien intelligence living in the ocean. It is a mirror, showing us possibilities of what intelligence can look like outside the human brain. While humans developed one large centralized brain, the octopus developed many small brains distributed across its arms. Both approaches work. Both are intelligent, but they are fundamentally different. And that difference matters for our future. Scientists studying octopuses believe that understanding their nervous system could inspire new approaches to artificial intelligence. Imagine robots that think in a distributed way, with each limb having its own independent control system, just like an octopus arm. This is already being tested in some research labs. Future technology might move away from one central processor and toward networks of semi-independent processors that work together like an octopus body. In that sense, the octopus may hold secrets not only for biology, but also for the machines of tomorrow. But there is another side to the story. The oceans are changing. Climate change and pollution are reshaping the habitats where octopuses live. Warmer waters, plastic pollution, and collapsing ecosystems are challenges they may not survive if nothing changes. The truth is simple. The future of octopuses is tied to the future of humanity. If we continue to destroy the seas, the octopuses will disappear, and with them, one of the most extraordinary examples of intelligence that evolution has ever created will vanish forever. But if we protect the oceans, if we respect these creatures, there is another path. One where octopuses and humans share a future. It is not science fiction to imagine undersea research stations where scientists and octopuses interact, where we learn from their behavior and they adapt to our presence. Already, experiments have shown that octopuses recognize human faces, that they can interact in ways beyond simple animal responses. What if, in the future, we find a way to communicate more directly with them? They have intelligence, they have memory, they have problem-solving skills. What they lack is language in the human sense. But perhaps new technology, combined with our growing understanding of their brains, will one day allow some form of dialogue. If that happens, then the idea of humans and octopuses sharing a common future will no longer be fantasy. It will be reality. This future, however, depends on choices we make today. Will we continue to overfish the seas, pour plastic into the waters, and heat the oceans until ecosystems collapse? Or will we take the path of preservation, seeing in the octopus not just an animal, but a partner in the story of life on Earth? The octopus, with its 3 hearts, 9 brains, blue blood, and magical camouflage, is already a symbol of survival. It has endured for more than 300 million years, long before humans ever walked on land. If we respect that survival, we may find that our futures are more connected than we realize. Think of it this way. The human story and the octopus story are running side by side. We are land creatures, building cities and machines. They are ocean creatures, building strategies of disguise and survival. But both of us are intelligent beings, navigating the challenges of a changing planet. Perhaps one day our paths will merge more directly. Perhaps one day we will recognize that the octopus has always been more than just another animal. It has been a teacher, showing us what intelligence can become when shaped by different circumstances. And as we look toward the future, that lesson may be one of the most valuable we can learn. If you are enjoying this story, don't forget to subscribe to the channel and leave a like. Every night we bring you new journeys into the mysteries of nature, so stay with us and never miss the next adventure. Octopuses are the true magicians of the ocean. When we talk about invisibility, we usually think of science fiction movies or magical cloaks. But in the real world, the octopus has already mastered the art with just a thought. Its skin can shift color, pattern, and even texture. Within a fraction of a second, it can disappear into a background of coral, vanish against the sandy bottom, or turn into a shadow among rocks. This ability is not only beautiful, it is one of the most sophisticated biological tricks in nature. The secret lies in specialized cells called chromatophores, iridophores, and leucophores. Chromatophores contain pigments of yellow, red, brown, and black. Iridophores reflect light in shimmering greens and blues. Leucophores scatter light and mirror the environment. Working together, these cells create a living canvas more advanced than any technology humans currently possess. Imagine standing in front of a wall that shifts and changes to match every detail of your clothing, your skin, your shadow. That is what an octopus can do with its body in the wild. Scientists studying them under laboratory conditions have been amazed at how precise the camouflage can be. The octopus does not only copy the color of a rock, it copies its fine texture, its shadows, even the direction of the light. This is invisibility on an almost supernatural level. But the question is not just how they do it. The question is why. Camouflage is essential for survival. Octopuses are soft-bodied animals. Unlike fish with scales or turtles with shells, they have no protective armor. They are vulnerable to predators, from sharks to eels to larger fish. Their only defense is to vanish. By becoming invisible, they avoid the fight altogether. But invisibility is also a hunting tool. By blending into the surroundings, the octopus can creep close to prey without being seen. When the right moment comes, it strikes with speed, and the prey never even understood what was happening. This combination of defense and offense shows how critical camouflage is to the octopus lifestyle. It is not a trick for beauty. It is a matter of life and death. Humans often admire this ability and wish we could replicate it. Military scientists dream of uniforms that change color like an octopus. Fashion designers imagine fabrics that shimmer and shift in real time. Biologists study the mechanisms in detail, hoping to unlock the secrets. Yet beyond technology, there is something deeper. The octopus reminds us that intelligence and adaptation come in many forms. An animal that cannot fight with claws or teeth instead develops invisibility. Nature balances weaknesses with strengths. And this principle is one that humanity can learn from. When we look at the brain of the octopus, we see a system that is unlike our own. The octopus has distributed intelligence, with each arm controlling itself in part. This means problem solving can happen locally in the arm, without waiting for commands from the central brain. When researchers placed puzzles in tanks, octopuses often solved them with surprising speed. They unscrewed jars, navigated mazes, even manipulated tools. They demonstrated memory, both short-term and long-term. They recognized patterns. They learned from experience. These are traits we usually associate with higher vertebrates like birds and mammals. Yet here we see them in a creature so different from us, it feels alien. This leads to one of the most astonishing debates in science. Could the intelligence of the octopus be comparable to human intelligence in certain domains? Of course, they cannot build cities, write books, or use language like we do. But within their environment, within the rules of the ocean, they may be just as capable. Some scientists argue that octopuses demonstrate what is called convergent evolution. This is when very different species evolve similar traits because they face similar challenges. For humans and octopuses, the challenge was intelligence. We built tools, they built strategies of camouflage and escape. We wrote language, they wrote their knowledge into distributed brains. Both paths lead to survival. Both are valid. And this is where the story connects to our own future. If intelligence can evolve in such different forms, then humanity must broaden its definition of what it means to be smart. Intelligence is not only about human standards. It is about adaptation, creativity, and solving problems within a given environment. The octopus excels at this. In fact, in some ways, the octopus outperforms us. It can change its skin faster than any human can change clothes. It can squeeze through openings the size of its own eye, something our rigid skeletons make impossible. It can learn without language, without schools, without culture. Its intelligence is embodied, physical, and immediate. When you think about this long enough, the octopus begins to feel like a mirror held up to us. We see in it another way that life on Earth has discovered thought. Not thought in sentences or words, but thought in colors, movements, and patterns. And this is where the comparison becomes truly interesting. Humans are building machines that mimic intelligence. Artificial intelligence is growing in complexity, but most of it is centralized, focused in processors and servers. What if instead we looked to the octopus model? What if we designed machines with distributed intelligence, each part acting semi-independently, yet coordinated? That would be a system inspired directly by the octopus body. Some robotic engineers are already working on soft robots modeled on octopuses. These robots bend, squeeze, and adapt just like the animals do. They can navigate tight spaces, grip objects gently or firmly, and even learn from mistakes. They are not only inspired by the body of the octopus, but also by its brain. This is the bridge between octopus intelligence and human technology. It is a meeting point where biology and engineering overlap. But there is more. Beyond science and machines, there is the question of connection. Could we one day communicate with octopuses in a way more advanced than gestures and observation? We know they recognize humans. They can distinguish between different faces. They can show preferences and emotions, squirting water at people they dislike and approaching those they trust. These are the beginnings of relationship. What if future technology allowed us to map their brain activity more precisely? What if translation devices were built not for language, but for patterns of signals? A human speaks in words. An octopus might speak in colors and movements. Bridging that gap would be one of the greatest achievements in interspecies communication. Imagine a world where humans and octopuses shared knowledge directly. They could teach us strategies of survival in the ocean. We could teach them tools and technologies. Together we could expand what it means to be intelligent life on Earth. This might sound like a dream, but it is rooted in real science. The more we learn about the octopus, the more we realize how close we are to this possibility. The key challenge is protecting them. Climate change, overfishing, and pollution threaten their habitats. Plastic fills the seas. Warming waters change ecosystems, and human activity reduces the balance of life in the ocean. If we do not act, the chance to build this shared future will disappear, and with it the octopus, one of the most remarkable minds ever to evolve, will vanish. But if we act with wisdom, if we protect the oceans, then a new chapter is possible. The octopus has survived for hundreds of millions of years. It has adapted through extinctions and climate shifts. If we respect its resilience and safeguard its world, it may thrive alongside us for many centuries to come. And perhaps in that shared time we will finally learn what it is like to think not as a human, but as an octopus. Perhaps we will discover that intelligence has more faces than we ever imagined. The octopus becomes invisible in the sea, but in our minds it should become more visible than ever. It is not a shadow. It is not only a creature of myths and legends. It is a living example of life's creativity. As we consider our future, let us not forget that we share this planet with minds that are different yet powerful. The art of invisibility is not only a survival trick. It is a message that intelligence does not always need to be seen to be real. A message that sometimes the greatest secrets of nature are hidden in plain sight. And a message that humanity, if it wishes to survive, must learn to see what is invisible. The octopus shows us this path. The question is whether we are ready to follow. The ocean is a place of endless change. Light fades as you go deeper. Shadows stretch across the rocks. Fish dart in every direction, and predators move silently through the water. In this ever-shifting environment, the ability to blend in is one of the greatest tools for survival, and no creature has mastered this art more completely than the octopus. Color change is not an accessory for them. It is their language, their protection, their hunting strategy, and their performance on the stage of the sea. To understand the perfection of octopus camouflage, we have to look beneath their skin. Embedded in the tissue are cells called chromatophores. Each chromatophore contains a sac of colored pigment. Tiny muscles expand or contract these sacs in response to signals from the nervous system. When expanded, the color shows brightly. When contracted, the cell becomes invisible. By controlling millions of these cells in a coordinated dance, the octopus can change its entire appearance in less than a second. But chromatophores are only the first layer. Beneath them lie iridophores and leucophores. Iridophores reflect light like mirrors, creating shimmering greens and blues. Leucophores scatter ambient light, acting like a white canvas that adjusts to the colors around it. Together, these three systems create a living display more advanced than any human screen or projector. Imagine a body that can become striped, spotted, or completely uniform at will. Imagine a creature that can match not just the color, but also the brightness and contrast of its surroundings. That is what an octopus can do. Scientists have filmed octopuses vanishing into coral reefs so perfectly that the camera had to zoom in closely to reveal them. Divers swimming past sometimes never realize an octopus was right beside them. This invisibility is essential because octopuses are soft-bodied. They have no bones, no armor, no spines. Their only defense is to not be noticed at all. Yet the beauty of their camouflage is that it is not only for hiding, it is also for hunting. An octopus will flatten its body against a rock, changing its color to match the surface. It waits motionless as fish pass by. Then, in a flash, it leaps forward, arms spreading like a net. The prey never had a chance. The camouflage turned the octopus into a ghost until the very moment of attack. Some octopuses use moving patterns, like waves rippling across their skin, to confuse both prey and predators. Others mimic specific objects in the environment, like seaweed swaying in the current. One species, the mimic octopus, can imitate the appearance and movements of other animals entirely. It can look like a lionfish with striped arms extended, or like a flatfish gliding along the bottom, or even like a sea snake. Each disguise is chosen depending on what predator it is trying to fool. This is not random trickery. It is strategy, and strategy requires intelligence. The octopus must observe its environment, choose the right disguise, and execute it instantly. It is as if the ocean gave them a toolbox of identities, and they know exactly which one to wear at any given moment. For humans, this ability feels like magic. Our clothing is fixed. Our skin does not change color on command. We rely on external tools for disguise. The octopus carries its tools within itself. Biologists believe this adaptation is one of the key reasons octopuses have survived for more than 300 million years. In a world full of predators, invisibility is life. But camouflage is also a form of communication. Octopuses use color not only to hide, but also to signal. A male approaching a female might flash patterns to display his presence. A threatened octopus might turn dark to look larger and more dangerous. Some species display bright warning colors when attacked, as if shouting, "Stay away." These signals are not spoken words, but they are language in a different form. A language of light and pattern. For humans studying octopuses, this challenges our narrow view of communication. We often assume language requires sound, symbols, or writing. But here we see a system of language that is visual, immediate, and deeply tied to the body. It reminds us that intelligence can find expression in many ways. It also raises questions about how we might one day communicate with octopuses more directly. Could we learn to read their patterns the way we read human facial expressions? Could technology one day allow us to interpret their flashes and ripples as sentences? These questions are not science fiction. Researchers are already mapping octopus behavior to specific color changes, building a vocabulary of signals. Perhaps one day we will understand their visual language more clearly. Beyond science, there are human dreams connected to this ability. Engineers imagine military uniforms that shift like octopus skin, making soldiers invisible on the battlefield. Designers imagine clothes that change pattern according to mood. Environmentalists imagine structures that blend seamlessly into natural landscapes. All of these dreams come from studying the octopus. Yet while humans try to copy the tricks, the octopus simply lives them. It does not think of camouflage as invention. It thinks of camouflage as existence. Each day, in every moment, its skin is a living interface with the world. The question for us is what we can learn from this. The octopus shows that survival is not only about strength or speed. It is about adaptability. It is about becoming what the situation requires. Humans to face environments that change. Our climate shifts, our societies transform, our challenges multiply. Perhaps the lesson of the octopus is that adaptation can be our greatest strength. If a soft-bodied animal with no armor can survive hundreds of millions of years by learning to change, then maybe humanity can survive its own trials by doing the same. As we move into a future of uncertainty, with ecosystems changing and technologies reshaping our lives, the art of camouflage becomes a metaphor. For the octopus, it is about hiding from predators and surprising prey. For us, it might be about learning to live within new realities without breaking. Both forms of camouflage are strategies of survival, and both remind us that flexibility is power. In the silence of the ocean, the octopus tells us this story with every color shift, every ripple of pattern, every perfect disguise. It is a reminder that nature has already solved problems we are only beginning to face. It is an invitation to look more closely, to see what is hidden, and to understand that sometimes the most powerful answers are written not in books, but in living skin. The octopus vanishes, but in doing so, it reveals a truth. To survive, you do not always need to be stronger. Sometimes you simply need to be unseen, adaptable, and infinitely creative. When danger comes in the ocean, most creatures must choose between fight or flight. But the octopus has created a third option, one that is as dramatic as it is effective. When threatened, it releases a cloud of ink, a dark smokescreen that confuses predators and buys the octopus precious seconds to escape. This strategy has made the octopus famous, almost mythical, and it is more complex than many people realize. The ink of an octopus is not just a random black liquid. It is a carefully evolved substance produced in a special sac connected to the digestive system. When the octopus contracts its muscles, the ink is expelled forcefully through the siphon, mixing with water to create a dense, billowing cloud. This cloud does two things. First, it blocks the vision of the predator, creating confusion. A shark, a moray eel, or a larger fish suddenly finds itself surrounded by darkness, unable to see where its prey has gone. Second, the ink contains chemicals that dull the predator's sense of smell and taste. It is both a visual and chemical weapon, designed not to hurt, but to disorient. This is the brilliance of the strategy. The octopus does not need to fight. It does not need to risk its soft body against teeth and claws. It simply creates chaos and vanishes. Some octopuses take this one step further. They do not only release a cloud, they release what scientists call a pseudomorph, or a false body. This is a blob of ink shaped like the octopus itself. As the predator attacks the decoy, the real octopus slips away unnoticed. To think of an animal capable of creating a dummy version of itself in the heat of danger is to realize how sophisticated these escape tactics really are. But the ink cloud is not the only trick in the arsenal. Octopuses are masters of physical escape as well. With no bones and a body made of soft muscle, they can squeeze through holes no larger than their eyeball. Aquariums around the world have stories of octopuses escaping their tanks, crawling across floors, and slipping through tiny drains back into the ocean. Their bodies are liquid and flexible, making barriers almost meaningless. Combine this with their intelligence, and you have one of the most elusive creatures on Earth. When threatened, an octopus may use a combination of strategies. It can change color to blend into the environment, suddenly jet backward by expelling water through its siphon, and then release an ink cloud behind it. This creates a triple defense: camouflage, speed, and confusion. Few predators can overcome this combination. For humans watching this behavior, the ink cloud is almost poetic. It is like a magician throwing down a smoke bomb and disappearing from the stage. It is performance and survival combined. But it is also a reminder of the creativity of evolution. The octopus is not built for brute strength. It is built for cleverness, for invention, for strategies that outwit rather than overpower. There is a lesson in this for us. In our own lives, when danger or challenge comes, do we always need to fight directly? Or can we sometimes create our own smokescreens, our own ways to escape without harm? The octopus shows us that survival does not always mean confrontation. Sometimes it means diversion. Sometimes it means thinking differently, Biologists studying octopuses believe the ink defense evolved over millions of years as a response to a wide variety of predators. In shallow waters with many threats, the ink is especially valuable. In deeper waters, where visibility is lower, the strategy may be less about sight and more about smell. The chemicals in the ink disrupt the sensory abilities of predators that rely on smell, such as eels. In either case, the principle is the same: confuse the enemy and escape. This is not cowardice. It is efficiency. It is survival by intelligence rather than force. Some cultures in human history have even seen symbolism in octopus ink. In ancient times, it was harvested and used for writing and dyeing. The idea that a creature defends itself with the same substance humans use to record thoughts and stories is strangely poetic. The ink becomes a bridge between their survival and our communication. In modern science, the chemistry of the ink is studied for potential uses in medicine. Some compounds show promise in health research. Once again, the octopus provides more than just mystery. It provides inspiration. Yet the most fascinating part remains the escape itself. Watching an octopus vanish in a puff of darkness is to witness a performance perfected by evolution. It is a reminder that life finds endless ways to adapt, and it is a symbol of resilience. The octopus tells us through its ink that when threatened, you do not need to be the strongest. You need to be the smartest. You need to create space for yourself to survive. In the story of humans and octopuses, this idea connects us more than we might think. Our ancestors survived not by being stronger than lions or faster than wolves, but by outsmarting them, by creating tools, by using fire, by finding strategies. The octopus mirrors this path in its own watery world. It creates tools from its body. It builds strategies from its biology, and it survives. As we face our own challenges today, from climate change to social conflict, perhaps the lesson of the ink cloud is worth remembering. When the world becomes dangerous, sometimes the best path is not direct battle, but creative escape. A chance to live another day and fight in smarter ways. The octopus has written this lesson in the ocean with every puff of ink. The question is whether humanity is wise enough to read it. In the silent world of the ocean, the octopus is a shadow moving with purpose. It is not a reckless hunter chasing its prey in open water. It is a patient strategist, a master of ambush and deception. To understand how an octopus hunts, we need to imagine life from its perspective. With no bones and a soft body, it cannot rely on brute strength to overpower enemies. Instead, it relies on stealth, intelligence, and adaptability. The hunt begins with observation. An octopus will often settle into a crevice or flatten itself against a rock, its skin shifting color and texture to blend perfectly with the It becomes invisible to fish and crabs swimming nearby. Hours can pass while the octopus waits unmoving. Then, when the prey drifts close enough, the octopus strikes with astonishing speed. Its arms shoot out in all directions like nets. Each arm, lined with powerful suckers, grabs and holds the struggling animal. There is no escape once the grip is made. The prey is drawn toward the beak, a sharp black structure hidden at the center of the arms. This beak can crack shells, pierce flesh, and deliver venom. The victim is subdued in moments. Yet, not every hunt follows the same script. Octopuses are creative hunters. They use tools and tactics depending on the prey and the environment. Some octopuses carry shells and rocks, using them to block the entrance of a crab burrow. Once the crab is trapped, the octopus patiently reaches inside to drag it out. Others have been observed stacking coconut shells to create shelters from which they launch surprise attacks. These are not instinctive reflexes alone. They are acts of problem solving that show a level of intelligence rare among invertebrates. In coral reefs, octopuses sometimes stretch their arms across large areas, creating barriers that corral fish into confined spaces. Once the fish are cornered, the octopus simply plucks them from the group. This cooperative behavior even extends to other species. Divers have recorded octopuses hunting alongside groupers and eels. The grouper signals with headshakes and gestures, leading the octopus to hidden prey. Together they flush out fish from crevices, sharing the reward. Such alliances show that octopuses are not only hunters, but also partners, capable of coordination across species. Jet propulsion is another tactic. By expelling water through their siphons, octopuses can surge forward, suddenly enveloping prey before it has time to react. Combined with a cloud of ink released behind them, this movement becomes even more effective. The prey is stunned, confused, and caught in seconds. Venom plays a role too. Many octopuses inject a paralyzing saliva into their victims. The blue-ringed octopus, one of the most famous species, carries venom so strong it can kill humans. But most species use their toxins primarily to immobilize small prey like crabs, snails, and fish. The venom liquefies flesh, making it easier to consume. It is a chemical weapon hidden in a seemingly fragile body. What makes octopus hunting extraordinary is not only the methods, but also the flexibility. They adapt to new challenges quickly. In laboratory experiments, octopuses have learned to open jars, unscrew lids, and navigate mazes to reach food rewards. They remember solutions and apply them again later. This memory, combined with keen eyesight and sensitive touch, gives them an edge over many prey animals. Their suckers are particularly impressive. Each sucker can grip independently and taste the surface it touches. Imagine a hand with hundreds of fingers, each capable of feeling and tasting at the same time. That is how an octopus explores its prey. It is an intimate sensory experience, one that guides their hunting decisions. Prey animals in the ocean have evolved defenses too. Crabs have shells. Fish swim in schools. Some hide in narrow crevices. Yet the octopus often finds ways around these defenses. It can insert a slender arm into a crack and pull the animal out. It can patiently wait until the prey makes a mistake. It can use camouflage to get close enough that the victim never realizes the danger until it is too late. This interplay between predator and prey is part of the larger balance of the ocean. The octopus is not a mindless killer. It hunts because it must survive. And in doing so, it shapes the populations of fish, crabs, and other animals in its habitat. Each hunt is part of a cycle that has been running for millions of years. For humans studying octopus hunting strategies, there is both fascination and inspiration. We see in them a reflection of our own hunting past, when humans tracked animals with patience and strategy rather than speed or strength. We also see lessons for the future. The adaptability of the octopus shows that intelligence is not about following one rule. It is about reading the environment and choosing the right tactic for the moment. This is a lesson that applies not only to hunting, but to life itself. In a world that is constantly changing, survival belongs to those who can change with it. Watching an octopus hunt reminds us that intelligence comes in many forms. It can be silent, waiting, hidden under rocks. It can be sudden and explosive, striking with precision. It can be cooperative, working with other species for mutual gain. And it can be inventive, turning shells into tools and ink into weapons. All of this is intelligence embodied in a creature so different from us, yet strangely familiar. The hunting strategies of the octopus reveal the truth about nature. Survival is not always about power. It is about creativity. It is about patience. It is about the ability to see possibilities where others see walls. As the octopus stretches its arms into the reef, pulls a crab from its hole, and disappears again into the shadows, it teaches us this lesson silently. In the endless theater of the ocean, the octopus is not just a predator. It is an artist of survival. In the vast blue world of the ocean, even the most skilled hunter eventually becomes prey. The octopus, with its 3 hearts, 9 brains, and unmatched intelligence, is not invincible. It has enemies, powerful and relentless. Among these enemies, the most feared are the sharks. The relationship between octopuses and sharks is a silent dance of survival, a battle of wits and instincts that has played out for millions of years. Sharks are fast, strong, and armed with rows of sharp teeth. They are apex predators, capable of sensing the faintest movements in the water. Against such power, the octopus appears fragile. Its body is soft, with no bones and no protective shell. But fragility does not mean weakness. The octopus meets the shark, not with brute force, but with strategy. When a shark approaches, the octopus has seconds to act. It might flatten its body against the ocean floor, turning pale to match the sand. The shark swims overhead, searching, but sees nothing. Sometimes, the octopus wedges itself into a rocky crevice, pulling its arms in tightly. The shark circles, unable to reach inside. If the shark grows too close, the octopus has another defense. It ejects a dark cloud of ink, filling the water with confusion. The shark lunges into the cloud, snapping at shadows, while the octopus slips away unseen. This is the first layer of the dance. Hide, misdirect, escape. But the story does not end there. There are times when the shark wins. Divers have observed sharks tearing octopuses apart in sudden, brutal attacks. A single mistake in camouflage or a second of hesitation can mean death. The ocean is merciless, and even the smartest hunter cannot survive every battle. Yet, there are also moments when the octopus turns the tables. In shallow waters, there are rare accounts of octopuses ambushing small sharks. With astonishing speed, they coiled their arms around the shark's body, pinning its fins and restricting its movements. The suckers grip tightly, and the shark struggles, but cannot free itself. In these encounters, the octopus demonstrates not only defense, but dominance. Such moments remind us that the line between predator and prey is not fixed. It shifts with size, with environment, with timing. For humans watching this dance, it is a revelation. We often think of sharks as unstoppable killers and octopuses as clever but weak. Yet the truth is more complex. Nature is not a story of winners and losers. It is a story of balance. Each animal plays its role. Each adapts to survive. The shark forces the octopus to perfect its camouflage, its agility, and its quick thinking. The octopus forces the shark to sharpen its hunting senses and persistence. Together they shape one another in an endless evolutionary game. The dance extends beyond sharks. Moray eels also hunt octopuses, diving deep into crevices where camouflage is useless. Dolphins sometimes play cruel games with octopuses, tossing them through the water. Even seabirds hunt them when they venture too close to the surface. The octopus lives in a world filled with danger from every direction, and yet it survives. It has survived for hundreds of millions of years precisely because of these dangers. Predators push it to evolve. Enemies force it to invent new strategies. Without the pressure of sharks, perhaps the octopus would not be as intelligent as it is today. In this way, natural enemies are not only threats, they are teachers. The shark teaches the octopus to vanish more quickly, to anticipate movement, to use its ink more effectively. The octopus teaches the shark to be more cunning, to look beyond simple sight, to rely on other senses. This is why we call it a dance. It is not hatred. It is not cruelty. It is survival woven into the fabric of the sea. Humans, too, are part of this story. For centuries, people have feared sharks and admired octopuses. In myths, the shark is a monster and the octopus a shapeshifter. But when we watch them together in reality, we see two forms of intelligence facing one another. One built on strength, speed, and instinct. The other built on flexibility, creativity, and deception. It is almost like watching two philosophies of life collide. Which one is better? Which one will survive? The answer is that both survive, because the ocean needs both. The balance of predator and prey keeps ecosystems stable. If sharks vanished, prey populations would explode, damaging reefs and fish stocks. If octopuses vanished, the same would happen with crabs and mollusks. Each enemy sustains the other's existence by keeping balance. For humanity, this truth is important. When we disrupt the ocean by overfishing or pollution, we break these dances. We remove one partner and the other falters. Protecting sharks and octopuses alike means protecting the health of the ocean itself. Perhaps one of the most striking images is the moment when an octopus and a shark face each other in shallow water. The shark circles powerful and direct. The octopus hovers near the rock's fluid and unpredictable. One is raw force, the other is strategy. One charges forward, the other dissolves into shadow. The outcome is never guaranteed. Sometimes the shark wins. Sometimes the octopus wins. Always the ocean continues its dance. For us, it is a lesson in humility. Intelligence does not always guarantee victory. Strength does not always dominate. Survival is a balance of many factors: timing, luck, environment, and adaptability. In the long history of life on Earth, this balance has allowed both sharks and octopuses to thrive side by side. The dance will continue long after us unless we interfere too much. When you close your eyes and imagine the deep sea, think of this dance. Think of the shark, swift and hungry. Think of the octopus, silent and cunning. Their story is not only about predator and prey. It is about the creative tension that drives evolution. And it is a reminder that every life, no matter how strong or fragile, is part of a larger rhythm. The octopus dances with sharks, not by choice but by necessity. And in that dance lies the beauty of survival. The story of the octopus does not begin with the living animals we see today, hiding in reefs or gliding through shallow seas. It begins deep in time, in ages so ancient that continents were unrecognizable and oceans stretched endlessly across the planet. To understand the octopus fully, we must follow its fossil trail. But here we encounter the first mystery. Octopuses are soft-bodied creatures. They have no bones, no shells, no armored plates that resist the ages. When an octopus dies, its body decays, quickly leaving almost nothing behind. This is why their fossil record is so scarce. For a creature that has lived for more than 300 million years, there are only a handful of fossil remains scattered across the world. Each discovery is precious because it offers a rare window into the past. The oldest known relatives of modern octopuses date back to the Carboniferous period, more than 300 million years ago. These ancient animals looked different from the octopuses we know today. They belonged to a larger group of cephalopods, creatures that include squids, cuttlefish, and nautiluses. Unlike octopuses, some of these early cephalopods had internal shells which fossilized more easily. From them, we can trace the lineage, slowly leading toward the soft-bodied masters of camouflage we admire today. One of the most famous fossil finds was unearthed in Lebanon in deposits that date back nearly 95 million years. Incredibly, the fossils preserved not just outlines of bodies, but even traces of muscles and ink sacs. For paleontologists, this was a miracle because it confirmed that the basic body plan of the octopus has remained stable for tens of millions of years. The arms, the suckers, the ink defense were already present long before humans existed. This tells us that the octopus design was so successful it barely needed to change. Imagine that. While dinosaurs rose and fell, while continents shifted and climates transformed, the octopus body remained almost the same. It is as if nature perfected the design early and then simply let it endure. Fossils also reveal something about the spread of octopuses. Evidence suggests that early forms lived in shallow tropical seas, but over time they expanded into deeper and colder waters. Their copper-based blue blood gave them an advantage in low-oxygen environments. Their camouflage abilities helped them survive in diverse habitats. Slowly, they became one of the most widespread invertebrate predators in the ocean. Yet because fossils are rare, much of their history is written not in stone, but in inference. Scientists compare the genetics of living cephalopods to reconstruct their family tree. These studies suggest that octopuses diverged from their closest relatives, squids and cuttlefish, more than 275 million years ago. Since then, they have followed a unique evolutionary path, developing traits that set them apart. No other cephalopod has quite the same combination of intelligence, flexibility, and camouflage. To imagine their ancient world picture, oceans filled with ammonites, spiral-shelled relatives of the squid. Picture giant marine reptiles prowling above them. Picture coral reefs that look nothing like today's reefs. And among them small, soft-bodied ancestors of octopuses already practicing the art of survival. Each fossil we find is a message across time. It tells us that the octopus story is not a recent miracle, but a long, unfolding saga. They survived the Great Permian extinction when most marine life vanished. They adapted through the rise and fall of dinosaurs. They endured ice ages and climate shifts. Their persistence is almost unmatched in the animal kingdom. For humans, this fossil trail is more than science. It is a story of resilience. We look at these delicate imprints in stone and realize that intelligence is not only a human trait. It is a strategy life has been shaping for hundreds of millions of years. The octopus reminds us that survival can take many forms. Sometimes it takes the form of teeth and claws. Sometimes it takes the form of patience and camouflage. And sometimes it takes the form of soft bodies that leave almost no trace, yet outlast entire empires of creatures. Even today, scientists debate details. How many species of ancient octopuses existed? How exactly did they spread across the oceans? What pressures shaped their intelligence? Each fossil discovered adds a new clue, but the puzzle is far from complete. Perhaps that is fitting. The octopus is a master of hiding. Even its history hides from us. But we continue to search because, in these fossils, lies not only the past of an animal, but the story of adaptability itself. When you think of the fossil trail of the octopus, imagine time as an ocean and fossils as rare bubbles that rise to the surface. Each bubble tells us that life can endure in ways we do not always understand. Each bubble whispers that intelligence and survival are ancient companions. And each bubble reminds us that the octopus is not only a creature of the present, it is a survivor from deep time carrying secrets older than mountains and older than humanity itself. The octopus is not simply a creature of the modern seas. It is the heir of a lineage that stretches back over 300 million years into a world so different from our own that it seems like another planet. When we talk about the evolutionary mystery of the octopus, we are talking about a journey that began long before mammals existed, long before dinosaurs walked the land, and long before flowering plants spread across the earth. The mystery begins with the fact that the octopus is a soft-bodied animal. Soft bodies do not fossilize. Is bones, shells, and teeth become stone, but flesh vanishes quickly. This means that for creatures like octopuses, the fossil record is faint. It is a trail of whispers rather than a clear story. Yet despite this faintness, we know that octopuses are ancient because they belong to the cephalopod family. Cephalopods have been around for more than 500 million years. Their relatives, the ammonites and nautiloids, left behind spiraled shells that still appear in rocks across the world. From these shelled ancestors, the octopus line slowly diverged, shedding the armor and embracing softness. Why would a creature abandon a shell in a dangerous ocean? This is one of the great evolutionary puzzles. The answer lies in flexibility. Without a shell, the octopus became infinitely adaptable. It could squeeze into cracks and holes too small for armored creatures. It could escape predators by flowing like liquid. It could change shape, color, and even texture. The loss of the shell was not a weakness. It was a transformation that unlocked new possibilities. This choice made hundreds of millions of years ago shaped everything that followed. Another mystery lies in their intelligence. Most invertebrates operate through simple instincts. They act and react with little learning or problem solving. But the octopus evolved a nervous system so complex that it rivals that of many vertebrates. 9 brains distributed through the body networks of neurons, more dense than some mammals, memory, problem solving, creativity. How did such intelligence evolve in a creature so different from us? Some scientists suggest that the evolutionary arms race pushed octopuses toward intelligence. In a world filled with predators like sharks, marine reptiles, and later, large fish, the octopus needed more than camouflage. It needed strategy. The smarter the octopus, the better it survived. Over time, intelligence itself became a survival trait. Others argue that intelligence arose because of their hunting lifestyle. To capture prey hidden in rocks or buried in sand, the octopus had to innovate. Arms that could move independently became extensions of thought. Each successful strategy reinforced the development of brain power. Step by step across millions of years, intelligence became their weapon. This raises another fascinating question. Could octopuses represent a separate experiment in the evolution of intelligence? We humans like to believe that intelligence is unique to our branch of the tree of life. But the octopus shows that intelligence can bloom in very different soil. Their brains are not structured like ours. Their senses are not processed the same way. Yet they still learn, remember, and solve problems. This is why some scientists call them the closest thing to alien minds on Earth. If intelligence evolved twice on this planet, once in vertebrates like us, and once in invertebrates like them, then perhaps intelligence is not a rare accident, but a natural outcome of evolution when conditions demand it. This idea changes how we might look at life elsewhere in the universe. The evolutionary mystery deepens when we consider how little the octopus has changed. Fossils from 95 million years ago already show the same basic body plan we see today. 8 arms, suckers, ink sacs, camouflage abilities. Nature perfected the design early and has left it largely untouched. This stability contrasts with the constant change seen in other animals. Dinosaurs transformed into birds. Mammals diversified into thousands of forms, but octopuses remained octopuses. This suggests that their design was not only effective, but nearly unbeatable in its environment. In evolutionary terms, they found a strategy so successful that little improvement was needed, and yet mysteries remain. Why do they live such short lives, often only 1 or 2 years? Why do they die after reproducing, even though their intelligence could allow them to thrive longer? Why did evolution shape such brilliance, but pair it with fragility? These contradictions make the octopus one of the most puzzling creatures in nature. Their story is not one of steady progress, but of paradox. They are ancient but modern, fragile but powerful, short-lived but deeply intelligent. For humans, studying these mysteries offers more than curiosity. It offers perspective. We see in the octopus that survival does not require our kind of strength or longevity. Survival can be built on flexibility, on adaptation, on intelligence, spread through the body rather than concentrated in one brain. We also see that evolution is not a straight line. It is a branching path filled with experiments. The octopus is one of evolution's boldest experiments, and it succeeded beyond measure. In the darkness of the ocean caves, in the shifting sands, and among coral reefs, octopuses continue to live out this ancient legacy. Each camouflage, each hunt, each puff of ink is part of a story that began before. Humans existed and will continue long after us if we allow it. The 300 million year mystery of the octopus is not only about the past. It is about what intelligence means, what survival means, and what the future of life might hold. When we watch an octopus slip silently into a crevice, we are seeing the result of choices made by evolution long before our species appeared. We are seeing a creature shaped by pressures we can barely imagine. And we are reminded that the ocean holds secrets deeper than time. The octopus is both a puzzle and an answer, a mystery and a revelation, and its story continues to unfold with every generation that survives in the restless sea. Since the earliest days of human storytelling, the sea has been a place of wonder and fear. Vast, endless, and mysterious, it hides creatures that few people have ever seen. Among these creatures, none has inspired more fascination and dread than the octopus. Soft-bodied yet powerful, silent yet intelligent, the octopus became a symbol in myths and legends across cultures. To follow these stories is to follow the path of humanity's imagination as it tried to explain the mysteries of the deep. In the cold waters of the North Atlantic, sailors spoke of the kraken, a colossal octopus, or squid, so large it could pull entire ships beneath the waves. The kraken appears in Norse sagas as a terror of the seas. Fishermen told tales of huge tentacles rising from the water, curling around ships and dragging them down into darkness. These stories were born from fear, but also from truth. Giant squids and large octopuses live in those waters, and in ancient times when knowledge of the ocean was scarce, a glimpse of a tentacle or a carcass washed ashore was enough to spark legends that grew larger with each telling. In Japan, the octopus appears in folklore not only as a monster, but also as a trickster. Stories describe it as a shapeshifter able to disguise itself as rocks or even as human forms. In some tales, the octopus is a seducer luring people into the sea. In others, it is a wise guardian who saves fishermen from storms. The duality of the octopus as both danger and protector shows the complexity with which cultures viewed it. In Polynesian mythology, the octopus appears in creation stories. In Hawaii, the Kanaloa deity is associated with the octopus, a god of the sea and a symbol of deep knowledge. In some legends, the octopus is the last survivor of a previous world that was destroyed and remade. It clings to the ocean floor, carrying secrets from an earlier age. Such myths reflect the awe with which island cultures viewed the ocean and its inhabitants. In the Mediterranean world, octopus imagery appears in Minoan art from more than 3,000 years ago. Pottery from Crete shows octopuses with arms spread wide, covering the surface of jars and vessels. These images were not drawn as monsters, but as powerful symbols of the sea itself. The Minoans depended on the ocean for trade and food, and the octopus represented the abundance and mystery of those waters. In modern times, literature has kept the legend alive. Writers from Jules Verne to Victor Hugo describe giant cephalopods as terrifying adversaries. In Verne's 20,000 Leagues Under the Sea Captain, Nemo battles enormous squid in one of the most famous sea monster scenes ever written. Though the creature in the story is a squid, the image of curling tentacles wrapping around a submarine echoes the ancient myths of the kraken and the cultural memory of the octopus as a monstrous power. But myths are not only about fear, they are about meaning. Why did humans across cultures imagine the octopus in such ways? Part of the answer lies in its appearance. With 8 arms covered in suckers, its body moving like liquid, and its ability to vanish or change shape, the octopus seems otherworldly. It does not look like a fish. It does not behave like typical animals. For early humans who saw one in the wild, the octopus must have seemed like a creature from another realm. Another part of the answer lies in the sea itself. The ocean has always been a boundary for human imagination. It is vast, mysterious, and dangerous. To project fears and hopes onto its creatures was natural. The octopus with its alien body became a canvas for stories about the unknown. For us today, these myths may seem like exaggerations, but they carry a deeper truth. They tell us how humans tried to understand the world before science. They reveal our tendency to create symbols from the creatures around us. And they show that the octopus has always occupied a special place in our collective imagination. Even now in movies, books, and art, the octopus continues to inspire. From comic book villains with mechanical arms to animated characters portrayed as clever tricksters, the legacy of the octopus in myth still lives on. This matters because myths shape how we see reality. For centuries, sailors avoided waters they believed were haunted by giant octopuses. Fear guided behavior. At the same time, respect for the octopus as a powerful being encouraged cultures to honor the sea and its mysteries. These stories influenced how humans interacted with nature, and they still influence us today, even as science reveals the truth. The modern octopus is no longer a monster in the scientific sense. It is a highly intelligent animal with extraordinary abilities. But in another sense, the myths were right. The octopus is a kind of sea spirit, a creature that embodies mystery and creativity. It is both real and symbolic, both flesh and legend. When you close your eyes and imagine an ancient sailor standing on the deck of a fragile ship, staring into the dark waters, you can almost feel the fear and wonder. Somewhere below might be a shadow with arms reaching longer than the mast. Somewhere below might be the kraken. And whether or not the monster rises, the story is already alive in the sailor's mind. That is the power of myth. That is the legacy of the octopus in legends across the world. When we talk about intelligence, we usually think of ourselves. We measure intelligence by human standards, language, tools, culture, mathematics, art. For a long time, humans believed we were unique, the only true thinkers on Earth. But then we began to notice intelligence in other creatures. Dolphins with their complex communication, elephants with their memory, crows with their ability to use tools. And then there is the octopus, a creature so different from us that at first it seems impossible to compare. Yet when we look closely, we see that the octopus is intelligent in ways that both mirror and challenge our own. The octopus has 9 brains, 1 central and 8 smaller ones in each arm. This distributed intelligence means that problem solving happens locally as well as globally. A single arm can explore, manipulate, and even make decisions without waiting for instructions from the main brain. For humans used to a single centralized brain, this is a strange idea. Imagine your hands having independent thoughts, capable of solving puzzles, while your mind focused on something else. That is the reality for the octopus. Experiments show that octopuses can learn quickly. They can open jars, unscrew lids, navigate mazes, and remember solutions. They show both short-term and long-term memory. They recognize individual humans and respond differently to people they like or dislike. They can even use tools like coconut shells to build shelters. These are behaviors we often associate with primates. The fact that an invertebrate with a completely different evolutionary history shows them too is astonishing. When we compare octopus and human intelligence, one of the key differences is lifespan. Most octopuses live only 1 or 2 years. Humans live decades. We pass knowledge across generations through culture. Octopuses do not. Each individual must learn for itself. There is no teaching, no tradition in the human sense. Yet, despite this, they reach remarkable levels of problem solving within their short lives. It is as if evolution poured all of their potential into the individual rather than into societies. Humans, on the other hand, rely on shared knowledge. Our intelligence is cumulative. We build libraries, schools, and technologies that expand with each generation. Octopuses build nothing permanent, yet, in their brief time, they achieve feats of learning that rival animals with much longer lives. Another comparison lies in communication. Humans developed spoken and written language. Octopuses use colors, patterns, and body movements. Their skin becomes a screen, displaying warnings, invitations, and camouflage. While our language is symbolic and abstract, theirs is direct and embodied. Both are effective in their own contexts. Both show that intelligence seeks expression. Some scientists suggest that octopuses represent an independent origin of complex intelligence. Vertebrates, like humans, dolphins, and birds, share a common ancestry. Their brains evolved along similar lines. But octopuses are invertebrates with no bones, no spinal cords, and completely different nervous systems. Their intelligence evolved separately. This means that on Earth, intelligence has appeared at least twice in very different forms. That fact alone changes how we think about life. If it happened here twice, perhaps it is not so rare in the universe. Perhaps, wherever life evolves, intelligence is one of the possible outcomes. Comparing human and octopus intelligence also reveals contrasts in focus. Humans excel at long-term planning, cooperation, and cultural complexity. Octopuses excel at immediate problem-solving, adaptability, and physical intelligence. Their arms are both tools and thinkers. They can taste and touch simultaneously. They can control hundreds of suckers independently. This embodiment of intelligence is something humans can barely imagine. For us, intelligence is mostly in the brain. For them, it flows through the body. Yet despite the differences, there are surprising similarities. Both humans and octopuses are curious. Both explore their environments, manipulate objects, and test possibilities. Both show playfulness. In aquariums, octopuses have been seen playing with toys and streams of bubbles. Play is often considered a sign of higher intelligence. It suggests creativity beyond survival. This similarity hints that curiosity may be a universal trait of intelligent minds. The comparison also forces us to question our assumptions. We think of intelligence as a ladder with humans at the top. But perhaps it is not a ladder. Perhaps it is a tree with many branches. The octopus is one branch, humans another. Each evolved differently, but each reached complexity. To ask which is smarter may be the wrong question. The better question is, what does intelligence mean in each form of life? For humans, intelligence is about shaping the world, building civilizations, writing history. For octopuses, intelligence is about mastering the ocean floor, surviving predators, solving immediate challenges. Both are remarkable. Both deserve recognition. When we place them side by side, we see not competition, but diversity. We see that the universe allows intelligence to wear many faces. This realization is humbling. It reminds us that we are not alone in being thinkers. It reminds us that wisdom may exist in unexpected forms. And it challenges us to respect creatures that seem alien, but are in fact our companions on this planet. In the end, comparing human and octopus intelligence is not about ranking, but about understanding. It is about seeing that the octopus, with its 3 hearts, 9 brains, and blue blood, is not just an animal of instinct, but a mind of the ocean. It is about realizing that intelligence is not ours alone, but a gift life shares in many ways. And it is about imagining a future where humans and octopuses learn from one another, each teaching the other new strategies for survival. In that vision, intelligence becomes not a boundary, but a bridge. A bridge across species, across evolution, and across the mystery of what it means to think. The octopus is a creature of solitude. In the vastness of the ocean, where countless species swim in, schools hunt in packs or live in colonies, the octopus chooses another path. It lives alone, hidden in dens, under rocks, in crevices, or among corals. It is a lone hunter, emerging only to search for food or to mate. This solitary lifestyle is one of the most striking differences between octopuses and many other intelligent animals. To understand why the octopus lives alone, we must look at its biology, behavior, and the environment it inhabits. Unlike dolphins or elephants, which rely on social bonds for protection and learning, the octopus is soft-bodied and vulnerable. Living in groups would make them easier targets for predators like sharks and eels. Solitude reduces risk. A single octopus can vanish into the rocks, blending with the background. A group would be more visible, more vulnerable. Camouflage works best alone. There is also the matter of resources. Octopuses are predators that feed on crabs, fish, and shellfish. These resources can be scarce in certain areas of the ocean. If many octopuses lived together, they would compete fiercely for food. By living alone, each octopus secures enough prey for itself without conflict. Solitude is survival. Their intelligence also plays a role. Octopuses are problem solvers, capable of manipulating their environment. They build dens out of rocks, shells, and debris, creating personal fortresses. These dens are carefully arranged with entrances blocked by stones. The octopus moves into place. This behavior shows planning and effort, but it also shows independence. Each octopus builds its own home with no help from others. There is no shared construction, no communal living. The den is both a shelter and a symbol of solitude. Social behavior is limited mostly to reproduction, and even then it is brief. When a male meets a female, he approaches cautiously. Octopuses can be aggressive, and encounters sometimes end violently. Mating involves the male extending a specialized arm, called the hectocotylus, to transfer. After this exchange, they separate. The male soon dies, and the female retreats to guard her eggs. Once the eggs hatch, the female dies as well. There is no family unit, no care for young beyond the mother's final sacrifice. The offspring are left to drift in the plankton, learning to survive on their own. In this way, the cycle continues with solitude at its core. Some scientists suggest that the short lifespan of octopuses contributes to their solitary nature. With only 1 or 2 years to live, there is little time to form long-lasting social bonds. Intelligence is directed toward immediate survival rather than building complex societies. This is a stark contrast to humans whose long lifespans and extended childhoods make culture and cooperation essential. The octopus evolves individually, not collectively. Another reason for their solitude may be cannibalism. Octopuses are known to eat one another when food is scarce. Living alone reduces the risk of such encounters. Even in captivity, researchers must often separate octopuses to prevent them from attacking each other. They are not social companions, but independent hunters, each ruling a small territory of the sea floor. And yet solitude does not mean emptiness. The life of a lone octopus is filled with activity, exploration, and creativity. Each night it leaves its den to hunt, moving silently across the reef. Each day it rearranges its home, adding shells and stones. Each moment it adapts to its surroundings with camouflage and intelligence. Solitude is not a weakness, but a chosen path. It allows freedom, independence, and self-reliance. For humans used to valuing social connections, this way of life may seem lonely. But for the octopus, it is natural. It is the way it has survived for hundreds of millions of years. There is beauty in this independence. The octopus shows us that life can thrive without groups, without hierarchies, without constant interaction. It shows us that solitude can be strength. In a world where cooperation is often praised, the octopus reminds us that self-sufficiency has its own wisdom. Still, the solitary life of the octopus does not prevent it from interacting with the wider ocean. It participates in ecosystems, shaping prey populations and feeding predators. It influences coral reefs by hunting crabs and fish. Its discarded shells provide shelter for smaller creatures. Even alone, it is part of a larger web of life. The lesson is subtle but important. Solitude does not mean isolation. The octopus is solitary but not disconnected. It is alone but still woven into the fabric of the ocean. For humans reflecting on this way of life, the octopus becomes a mirror. We too sometimes choose solitude to think, to create, to find peace. In those moments we learn that being alone is not always being lonely. It can be a space of clarity. It can be a place where intelligence grows. The lone hunter of the sea teaches us this truth. As we watch it slip silently into its den, disappearing from view, we understand that solitude is not the absence of life. It is another form of life, another strategy, another wisdom shaped by evolution. The octopus is a reminder that in the vast and crowded ocean, there is still room for those who choose to walk or swim alone. The story of the octopus is not only about intelligence, camouflage, and survival. It is also about one of the most dramatic life cycles in the animal kingdom. To understand the octopus fully, we must follow it to the end of its journey, where mating and reproduction lead not to renewal for the parents, but to death. This tragic cycle is both heartbreaking and fascinating, a reminder that even in the ocean, life is written, with both beauty and sorrow. Most octopus species live for only 1 or 2 years. Their lives are short, intense, and filled with learning and adaptation. When the time comes to reproduce, the male searches for a female. He approaches with caution because octopuses are solitary and often aggressive. A wrong move can turn an encounter into violence. To avoid this, the male uses a special arm called the octopus to deliver. Sometimes he stretches this arm out carefully from a safe distance. In other cases, he climbs directly onto the female. The process is delicate and filled with risk. Once the transfer is complete, the two separate. For the male, the story is almost over. Within weeks, he weakens and dies. His role in the cycle is brief, a spark that passes quickly into darkness. The female now carries the responsibility for the next generation. She finds a safe den, a hidden place among rocks or coral. There she lays thousands of eggs, attaching them in delicate strings to the ceiling of her shelter. The sight of these eggs is like a curtain of pearls, swaying gently in the water. From that moment on, the mother devotes herself completely to their care. She cleans the eggs, constantly blowing water over them to keep them oxygenated, brushing away parasites and debris. She does not leave the den to hunt. She does not eat. All of her energy is focused on protecting the fragile lives growing inside those tiny shells. Weeks pass, sometimes months. The mother grows weaker, thinner, more fragile. But she continues her vigil, never abandoning her eggs. If a predator approaches, she defends the den fiercely despite her fading strength. Her life is now tied completely to the survival of her young. When the eggs finally hatch, tiny octopuses, no larger than grains of rice, drift out into the ocean currents. They rise into the plankton layer, carried by the sea. From the moment they are born, they are alone. The mother has given everything, and now her body fails. She dies quietly near the place where she gave life. It is a death that follows naturally from her sacrifice. For humans, this cycle seems tragic. We imagine intelligence paired with long life and family bonds. The octopus teaches us another story. It shows that intelligence does not always mean longevity. It shows that sometimes life is concentrated into a short span of brilliance. In those months, the female octopus displays devotion unmatched in the animal kingdom. She literally gives her life for the next generation. Some scientists call this semiparity, the strategy of reproducing once and then dying. Salmon do it. Certain insects do it. But in the octopus, it feels more poignant because we recognize their intelligence. We know that behind those watchful eyes is a mind capable of problem solving and curiosity. To see such a mind end in sacrifice is deeply moving. Why did evolution shape such a life cycle? One explanation is that it reduces competition between generations. If parents live longer, they might compete with their offspring for food and shelter. By dying after reproduction, the adults leave space for the young. Another explanation is that this strategy maximizes survival for the offspring. The mother's complete devotion during the egg stage ensures a higher chance of success, even if it costs her life. In either case, the result is the same. The cycle of birth and death is tightly linked. There are rare exceptions. In some deep-sea species, females guard their eggs for years, living without food for extraordinary lengths of time before dying. One female observed by scientists protected her eggs for more than 4 years, the longest known brooding period of any animal. Such dedication shows the extremes of this life strategy. For us, watching from outside, it is a lesson in sacrifice. We see in the octopus a reflection of values we hold dear, even if expressed differently. Devotion, care, that willingness to give everything for the next generation. These are qualities we recognize across cultures and species. In the octopus, they are written into biology itself. Yet there is also a lesson in impermanence. The octopus reminds us that life is not always about duration. It is about intensity, about the choices made within a brief span. Their short lives are filled with intelligence, exploration, and finally sacrifice. It is a cycle that has lasted for hundreds of millions of years and continues today in every ocean. When the tiny hatchlings drift into the current, they face immense odds. Most will not survive. Predators wait everywhere. But those that do survive will grow, learn, hunt, and one day repeat the cycle. The ocean continues its rhythm life, rising and falling with the tides. For humans, the story of the octopus life cycle is both sad and inspiring. It challenges our ideas of what intelligence means. It asks us to consider the value of sacrifice, and it shows us that even in the depths of the sea, life is written with stories as dramatic as any myth. When you close your eyes and picture a mother octopus guarding her eggs, brushing them gently with her arms, starving herself so they may live, you see devotion in its purest form. And when you imagine her final moments as the eggs hatch and she fades into stillness, you see the cycle completed. Life given, life taken, life renewed. The tragic cycle of death in the octopus is not a failure of nature. It is one of its most beautiful designs. For centuries, humans looked at the octopus with a mixture of fear, curiosity, and wonder. Sailors told tales of sea monsters, artists painted them on pottery, and poets used them as symbols of mystery. But in modern times, the octopus has taken on a new role. It has become one of the most important subjects in scientific research. The story of the octopus in science is not about myths. It is about discovery, and each discovery reveals more about the nature of intelligence, the flexibility of life, and the secrets of the brain. One of the main reasons scientists study octopuses is their nervous system. With 9 brains and more than 500 million neurons, octopuses are among the most neurologically complex invertebrates on Earth. Their arms can act independently, processing information without direct orders from the central brain. This decentralized intelligence has fascinated neuroscientists who want to understand how decision-making works outside the human model. By studying octopuses, researchers learn that intelligence does not have to be centralized. It can be distributed across a body. This has direct implications for robotics and artificial intelligence, where engineers seek ways to create machines that are more adaptive and flexible. Another area of research focuses on behavior. Octopuses solve puzzles, navigate mazes, and remember solutions. In controlled experiments, they unscrewed jars to get food, open boxes with locks, and even learn by watching other octopuses. These behaviors are rare among invertebrates. They show that the octopus brain is capable of learning flexibility and problem-solving at levels comparable to some mammals. For scientists, this makes the octopus a model for studying cognition. How does memory form in a brain so different from ours? How does problem-solving work without language? Each experiment brings us closer to understanding these questions. The octopus is also important in medical research. Their unique physiology offers clues about human health. Their blue blood carries oxygen using copper-based hemocyanin instead of iron-based hemoglobin. Studying this system helps researchers understand how oxygen transport works under extreme conditions. Their ability to regenerate lost arms offers insights into tissue repair and healing. If an octopus loses a limb, it grows back fully functional, complete with nerves and suckers. Scientists hope that understanding this process may one day lead to advances in regenerative medicine for humans. Even their camouflage abilities attract research interest. The chromatophores and iridophores in their skin create dynamic patterns that shift instantly. By studying these cells, scientists are developing new materials that change color and texture on command. Applications range from military camouflage to medical sensors to adaptive displays. In this way, the octopus contributes not only to biology but also to technology. The study of octopus ink has also revealed surprising results. The chemicals in the ink have antimicrobial properties and potential uses in medicine. Once seen only as a defense mechanism, it is now studied as a possible resource for human health. Everywhere scientists look, the octopus offers new knowledge. Ethical questions also arise. Because octopuses are intelligent, curious, and sensitive, researchers debate how they should be treated in laboratories. In some countries, octopuses are legally recognized as sentient beings deserving special care. This recognition is rare for invertebrates and reflects the respect scientists have gained for them. Studying octopuses has also changed how we think about consciousness itself. If an octopus can learn, play, and remember without a human-style brain, then consciousness may not be limited to creatures like us. It may be more widespread in the animal kingdom. This realization forces scientists, philosophers, and ordinary people to reconsider our place in nature. In classrooms and documentaries, the octopus now appears as a symbol of alternative intelligence. It shows children and adults alike that thinking can look different, that life finds many ways to solve problems, that the brain is only one design among many. And in the oceans, as researchers dive to observe them, in the wild, octopuses continue to surprise. They open clams with patience, pry crabs from their holes, and sometimes watch the humans watching them with eyes that seem filled with curiosity. These encounters remind us that science is not only about data, it is about wonder. For humanity, the role of the octopus in scientific research is therefore twofold. On one side, it provides practical knowledge that may transform technology, medicine, and neuroscience. On the other side, it challenges our imagination, expanding the boundaries of what we believe possible. The octopus is both subject and teacher, both experiment and inspiration. When we look at it in a tank or in the sea, we are not just studying an animal. We are looking at a mirror of what intelligence can be when shaped by a different path of evolution. The story of science and the octopus is still unfolding. Each year, new discoveries are made. Each year, the mystery deepens. And as we continue this exploration, we may find that the most valuable gift the octopus offers is not camouflage or venom or regenerative power. It is perspective. A perspective that intelligence is diverse, that life is creative, that survival writes many different stories, and that our place in the universe is shared with minds far stranger and more beautiful than we once imagined. When humans first began to dream of machines that could think, they looked at themselves as the model. We built computers that mirrored our own brains, centralized processors connected to memory systems, sending commands to dependent parts. But as research in artificial intelligence grows, scientists have begun to realize that there are other ways to design intelligence. And one of the most surprising sources of inspiration comes from the octopus. This creature with 3 hearts, 9 brains, and blue blood is not just a marvel of biology. It is a blueprint for new forms of technology. The octopus has a nervous system unlike any other. The central brain controls vision and coordination, but most of its neurons are in the arms. Each arm can act independently, exploring, manipulating, and even solving problems without waiting for instructions. This distributed intelligence is radically different from the centralized model humans use. For engineers designing robots, this idea is revolutionary. Imagine machines where each limb has its own processor capable of acting alone but also working together with the whole. Such a design would allow robots to be flexible, adaptive, and resilient. If one part fails, the others continue functioning. The octopus demonstrates this principle every day as it moves fluidly through the ocean, adjusting arms to currents, obstacles, and opportunities simultaneously. Roboticists studying octopuses have already built soft robots inspired by their bodies. These machines use flexible materials that bend, squeeze, and grip rather than rigid metal and joints. They can crawl through narrow spaces, grasp delicate objects without breaking them, and adapt to unpredictable environments. But the next step goes deeper. By copying the distributed intelligence of the octopus, these robots could learn and make decisions locally. Each arm could be its own thinker. Together, they would form a network of intelligence, not unlike a living octopus. This approach may redefine artificial intelligence itself. Instead of focusing on one powerful brain, we may design systems made of many small brains working in harmony. This could change how we build drones, how we design, search, and rescue machines, how we explore other planets. The octopus shows us that intelligence does not need to be singular. It can be collective within one body. Beyond robotics, the octopus inspires algorithms. Scientists study how its arms process information and translate those patterns into code. Distributed computing networks already mirror this principle, dividing tasks across multiple nodes. But the octopus suggests even more advanced methods, where decision-making is not just divided, but embodied. In the future, our artificial intelligence might not look like human thought at all. It might look like octopus thought, flexible, decentralized, adaptive. There is also inspiration in the octopus' ability to camouflage. Imagine artificial systems that change not only their software, but also their hardware on command. Materials that shift texture and color, like octopus skin, could make machines that adapt physically as well as mentally. The boundary between living and artificial would blur. Even the octopus way of learning offers lessons. In experiments, octopuses learn by trial and error, by exploration, by curiosity. They are not trained in the human sense. They discover. This style of learning resonates with machine learning, where algorithms explore possibilities and reinforce successful patterns. In this way, octopuses remind us that intelligence is not about following instructions. It is about exploring the unknown. The comparison goes further into philosophy. If octopuses represent an independent origin of intelligence, then artificial intelligence may represent a third origin. Life created one form in vertebrates like humans, and another in invertebrates like octopuses. Now humans may create a new artificial form. Each path is different, but each demonstrates that intelligence is not unique. It is a principle of survival that can appear wherever the conditions allow. By studying octopuses, we gain not only engineering ideas, but also humility. We see that our way is not the only way. We see that intelligence is not a ladder with humans at the top, but a spectrum with many possibilities. The octopus stands as proof that thinking minds can evolve in alien shapes. Artificial intelligence may become the next proof. The relationship between humans and octopuses in this field is therefore symbolic. The octopus is the living alien mind of Earth. Artificial intelligence is the artificial alien mind we are building. One comes from evolution, the other from invention. Yet both show that thought is flexible. Both show that survival favors creativity. And both may one day work together. Imagine a future where soft robots with octopus-inspired arms explore the deep-sea, learning from real octopuses as they move. Imagine machines designed for space exploration, adapting like cephalopods to the unknown terrain of other planets. Imagine distributed computer systems, managing global networks, resilient and adaptive like the nervous system of an octopus. These are not distant dreams. They are being built step by step right now. Every discovery about octopuses brings us closer. Every experiment with their behavior inspires new designs. Every observation of their camouflage or problem-solving plants a seed in human technology. The creature that once terrified sailors now guides scientists. The monster of myth has become the mentor of innovation. And in this transformation, we see how myths become science, how fear becomes wisdom. For humans, the octopus is more than an animal. It is a partner in the story of intelligence. It shows us what is possible when life thinks differently. It pushes us to create machines that are not copies of ourselves, but reflections of nature's diversity. And it whispers to us that intelligence is not fixed. It is a moving shape, like color on skin, like patterns in water, like thoughts in arms. The octopus teaches us that to be intelligent is to be adaptable. And if artificial intelligence learns this lesson, it may not only become smarter, it may become wiser. The ocean is the beginning of life on Earth, and it is also the stage where the story of the octopus has played out for more than 300 million years. Through mass extinctions, ice ages, and shifting continents, the octopus has endured. It has survived predators, it has solved problems, it has adapted with intelligence and creativity. But now it faces a challenge greater than sharks, greater than ancient reptiles, greater even than the long passage of time. The challenge is climate change and the growing influence of humanity on the planet. For the octopus, the sea is not only a home, it is everything. Temperature, oxygen, salinity, the chemistry of the water shapes its very existence. When the ocean warms even slightly, the life of the octopus changes. Its copper-based blood struggles to carry oxygen in higher temperatures. Its delicate eggs may not develop properly. Its prey moves to new waters or disappears entirely. What once was stable begins to shift, and the octopus must adapt or die. In many regions of the world, octopus populations are changing. Some species expand into new areas as waters warm, while others decline. For scientists, these movements are both fascinating and alarming. They show that the ocean is no longer the constant background it once was. It is a landscape in flux, driven by human actions. Pollution adds another layer of threat. Plastics fill the seas, tangling arms, suffocating hatchlings, poisoning food sources. Chemicals seep into the water, affecting delicate systems that octopuses depend on. The ink cloud that once saved them from predators cannot save them from camouflage that once fooled fish cannot hide them from nets. Intelligence that once solved puzzles cannot undo the acidification of oceans caused by carbon dioxide. The struggle of the octopus is therefore not a distant story. It is our story too. Humanity depends on the health of the oceans for food, for climate regulation, for life itself. If the octopus suffers, it is a sign that the entire marine system is under strain. The fate of the octopus and the fate of humanity are linked more closely than many realize. Yet in this struggle, there is also resilience. The octopus has survived dramatic changes before. It has adapted to darkness, to cold, to predators. It is possible that it may adapt again to new realities. But adaptation has limits. The speed of current change is unlike anything in the past. In just a few human lifetimes, oceans have warmed, polluted, and emptied faster than in millions of years of natural history. The question is whether the octopus can keep up. In this moment, humanity becomes not only a threat, but also a potential ally. We have the power to alter the course of this story. By reducing emissions, by protecting habitats, by respecting ecosystems, we can give octopuses and countless other species the chance to endure. Scientists working with conservationists already look to the octopus as a symbol of ocean protection. Its intelligence, its beauty, and its role in myth and science make it a powerful ambassador. When people see an octopus changing color, solving puzzles, or caring for its eggs, they feel wonder and connection. That feeling can inspire action. The shared future of humanity and the octopus depends on whether that wonder turns into responsibility. Imagine a world where octopuses still thrive centuries from now, where children dive into clear seas and see these creatures gliding through reefs. Imagine a world where technology inspired by the octopus helps humans solve problems without destroying nature. Imagine a future where the lessons of adaptability, sacrifice, and creativity that octopuses teach us are woven into how we live. That is the choice before us. A future with them or a future without them. For thousands of years, we told stories of octopuses as monsters and myths. Now we know them as intelligent companions. The final chapter of this story has not yet been written. It will be written by us, by our actions and our respect. As you listen to this story and drift toward sleep, remember that the ocean is alive with minds that are different from ours, but no less real. Remember that the octopus, with its 3 hearts, 9 brains, and blue blood, is not just an animal in the sea. It is a symbol of survival, a mirror of intelligence, and a partner in the shared journey of life on Earth. And now, dear listener, we have reached the end of our journey with the octopus. We have traveled through myths, through science, through the secrets of its body and the mysteries of its mind. We have seen it hunt, we have seen it hide, we have seen it sacrifice everything for the next generation. We have seen it dance with sharks, survive for hundreds of millions of years, and now face the greatest challenge of all the changes we humans bring to the ocean. As you close your eyes, let the image of the octopus stay with you, a reminder of the beauty of life and the responsibility we carry. If you enjoyed this story and want to continue exploring the wonders of prehistoric and modern creatures with us, do not forget to like this video and subscribe to the channel. Every night we will bring you new journeys into the mysteries of nature, stories to calm your mind and spark your imagination. Thank you for listening, thank you for dreaming with us, and remember, tomorrow another animal awaits, another adventure, another night together. Good night, sleep well, and see you in the next story.